Hola! It's me again. So, real quick, tests have been graded. They are in the grade book. They were great overall. You guys did a great job. I'll hand those back on Monday. And then, looking ahead, you have summaries due next Friday. I really can't implore you enough, maybe a vocab word if you need one, implore you enough to read with us. So what we talk about in class, either read before class or read right after that night. It just helps so much with memory, rather than just kind of cramming and doing the summaries but not reading. That is a big trap that people fall into. So please, I'm begging you to do that. So what we are doing Module 11 today. Alright, so that should be, if you haven't read it yet, that should be this weekend. And then, let me see. Yes, I would do 11 and 12. Those are the two that I would do. Okay? Because what's going to happen is we're going to get through the rest of this chapter, and it goes fast. There's a lot in here. It's a big chapter. And then the following Monday is your test. Alright? Okay. So, you have looked at the brain, how to study the brain. So now you're flipped over to some diagrams of what we're going to do. I'm going to have you label things, and then we're going to talk about each one as well. So what I would do on your packet is I would label them, and then take a few, what are the major functions of each one underneath. That's what I would write down. Okay? The end of this test, the test for this chapter looks basically like there's 30 maybe brain parts or something, and you need to know the function of each brain part. Alright, so in starting that, it's important to know that while we are going to say, oh, the thalamus on here is going to be known for doing this, you just can't group them and saying, oh, this part controls this part controls. We're not as separated as that. Our brain is a very integrated structure. It works together. So it's not like the first thing you saw, phrenology, of where there's all these different sections. Yes, we found locations that do deal more with memory or emotions. But that doesn't mean it works by itself. Alright? It's a good thing to remember. Okay. Alright, so first thing I would do is these are your older brain structures. What the heck does that mean, older? So, as humans have evolved, we have become more complex, right? Or even our brains have become more complex. It changes. Like if you think now about cell phones and the introduction of screens all the time, even that is changing the pathways and the neural pathways in our brain. So over time our brain has evolved, right? So when it says older, what it means is like early evolution of what is most, if you think even about like cavemen, for example, what is most important for their survival. They don't have this complex thinking as we do today. So older brain structures are things that help basic survival early on. Okay, so go ahead and label that at the top. The thalamus, the reticular formation, and then you got your brainstem with your pons and medulla. Give me a second for that. My goal is to maybe get through 2 or 3 of these. Then we're done for the day. Okay, pause me if you need to pause me. Okay, I'm just going to keep going. Okay, so down below, we already talked about what older means. Okay, so the brainstem down below, that is, if you look, so it's right here. The spinal cord enters into the brain. Alright? That's the oldest structure, and it is responsible for automatic survival functions. So I would write that like next to brainstem. Automatic survival functions. What helped them survive? Okay? Alright, so let's talk about those in particular. Alright, the medulla. Have you ever heard that before? Alright, medulla controls heartbeat and breathing. Heartbeat and breathing. And that is really, it's like at the base of your skull here, where your brain meets your spinal cord. So I have a story that goes along with this one. Maybe like 10 years ago now. They're in Georgia, I think Gwinnett County. Kind of a fight broke out on a school bus, and one kid just kind of, when I say fight, it wasn't all out, I'm going to kill this person. Kind of a stupid little fight. So one of the kids hits the guy in the back of the neck, right? Actually, he falls down and stops breathing. Heart stops beating. And it's because he was either hit right there with the guy's hand or he fell on it afterwards. So I always tell people, girls, sometimes you like want to slap your boyfriend or slap your friend over in the back of the head. It's not going to happen. Well, I'm not going to say not going to happen. But be careful. Don't nail them right at the base of the skull and stop their heart. Okay? Cool. There you go. There's your lesson for the day. Okay, so that's what medulla is. Alright? And then with your brainstem, it also, back to this picture, over here where it says pons, you can just write next to pons. They're known for coordination, being coordinated, walking, moving. If you think about that, that is an automatic survival function, right? Being able to be coordinated. Okay. The next one. Fun fact, we're going to make videos. You guys are going to make videos on you using all of these different parts of the brain. So keep that in the back of your head. Alright, reticular formation. So up here, alright, it's basically a nerve network. Let me move that. That is important in arousal. Allie, you're going to laugh at arousal again? So again, arousal here does not mean sexual arousal. It means in general alertness, right? How alert are you? Are you ready to go? Are you sleepy? Are you tired? You're not really with it. Okay? Now, I try to give them ways to remember these because that's what you're going to need to know. Reticular formation, an easy way to remember that, instead of reticular, something similar sounds like testicular formation. That might get you to think of arousal. So there you go. There's my way to remember it. Okay? So crazy thing. So what happens, a lot of questions you're going to get on multiple choice questions would be like, what would happen if the medulla was stimulated? So they can put like electrodes in there and stimulate it, right? So what would happen if the reticular formation was stimulated? Well, that means that function is stimulated, so super aroused and ready, right? Well, they did that to a cat that was sleeping, and it woke up and was ready to pounce. Now, then they actually severed it. They cut it, so it cannot communicate. What happens then? All right, cat lovers. It went, so it's the opposite. It went into a coma and never awoke again. So they had never had any arousal again in its life. Sad day. Okay. All right. The next one, here's my thing, is the thalamus. All right. That's on your page, yeah. The thalamus. All right. It is the sensory switchboard. Sensory switchboard. Now, what the heck does that mean? Okay. This is a switchboard. Back in the day, you had to call the operator and they would switch you to where you wanted to go. Right? Hi, I'd like to call Henry. Okay, well then they would switch you there. So, what the heck does the thalamus mean that they are the sensory switchboard? Well, what happens is your brain takes in information through your eyes, through your ears, through your hands, right? Your touch. And it goes to your thalamus. And the thalamus is the switchboard here. It says, oh, you need that information. You need to be processed in this part of the brain. You need to go to this part of the brain. So it is the switchboard there. It's another easier kind of way is it's the air traffic controller, maybe. It directs. It's the director. Okay, you need to go to this part of the brain. So it's kind of the first stop to getting processed. How do you remember this one? One of my students a long time ago said you got to talk about it in a Boston accent. Said no, that's not a Boston accent. Come on, the thalamus. I can't do it. The thalamus is calling us. There's the thalamus is calling us. And they said switch forward, and I don't know. Good luck with that one. Okay, we already did that. All right. Flip over. It's the one that looks like this. Well, I guess it's on the screen. Okay, I want you to label these two things. You got your spinal cord, which we've already talked about. That is part of what nervous system? Your central nervous system. Good job. I'm glad you said that. All right, and your cerebellum. Cerebellum. All right, so that's the one we're going to focus on, your cerebellum. Okay, they call it a little brain because it kind of looks like a little brain, and it's at the bottom of your brain. Okay, but what is the function here? All right, helps coordinate voluntary movements and balance. Voluntary movements and balance. Okay, voluntary movements. I'm moving my hands, right? I'm walking. How many of you would say that you have terrible coordination? Okay, maybe that is because you've had damage to your cerebellum. There could be a ton of different reasons, but who knows? Maybe that's it. Or maybe your cerebellum doesn't have as many neural connections as it should. Whatever. That is your cerebellum. Okay? So somebody like a professional athlete, LeBron James, I mean, his cerebellum is on fleek. Is that too, like, old school now? Not cool anymore? Okay, whatever. Alright, next page. Alright, I think this is the last one I'm going to do today. Yeah, I think so. Okay, so go ahead and label those. We'll talk about each one. Okay. In general, up there where it says limbic system, let's see if I have it on here. Okay, you can write that. The limbic system up top is this area. It's interesting looking, right? So if you slice the brain in half, this is what you would see. So it's internal. You can't. It's not on the outside of the brain. So in general, though, it is associated with emotions and then drives for food and sex. The limbic system. So maybe when you do like the limbo, you get emotional because you know if you win the limbo contest, you're going to get a cheeseburger afterwards. Yeah, that's how you remember that one. Okay, so these are the parts that are included, so let's talk about each one. Alright, the amygdala. No, it is not amygdala. Okay, amygdala. Okay, so it's pointing to amygdala. Alright, that's what I want you to put. It is linked to emotions of fear and anger. Fear and anger. So it is pretty crazy that through science we've been able to figure out that that little tiny thing inside your brain is linked to fear and anger, right? I think that's pretty cool. Okay? Okay, so let's go back to that idea of, let's say you stimulate that through electrodes. What do you think would happen if you stimulate it? So those emotions, right, get stimulated. But it's weird because it's like very close to each other. If you stimulate like one part, they could be very fearful. A cat would be scared, right, of something small like a mouse. But right over, if you stimulated it, it would be very angry. and get up and hiss, right? So that's kind of why there's two emotions there. Is there something else I want to tell you? Oh yeah. If you destroyed it, okay, which again they've done this in experiments. So they destroyed it or removed it. What happens to them? They become very mellow. Hey, I'm not scared. I'm not angry. I'm chill, bruh. Okay. So those are kind of questions they would ask. Alright, remember when we talked about the thalamus is calamus? Well, now you have the hypothalamus. Hypo means below. Fun fact. Okay? Alright. This, just so you know, the thalamus's function has nothing to do with the hypothalamus. Those aren't related. That's just, the name has to do with where it's located. Okay, so basically the hypothalamus has to do with maintaining your body at this even kind of state. We'll talk about homeostasis later. That's similar here. So the hypothalamus is involved with keeping your body maintained at this homeostasis level. Okay, so what does that mean? Sorry, headache. It is involved with eating, drinking, and body temperature. Those are your main ones. And control of emotions is kind of a side section, but eating, drinking, and body temperature. So if you think about it, eating, it would tell you when to eat, right? Because if you're hungry, your body is not in kind of homeostasis, right? So you need to eat, and then when you eat, then it brings you to that maintenance, that level of homeostasis. Same thing with drinking. Your body's not at homeostasis, so it helps it bring it back to normal. It tells you, hey, you need to drink, right? Or stop drinking. Same thing with body temperature. You're cold, it tells you, I'm cold, put on a jacket. Or you're hot, hurry and take off your clothes, just doesn't sound good. Take off your jacket, or else you're going to burn and die. Okay? So that's your hypothalamus. We talked about the endocrine system. Another thing is it kind of works through with the pituitary gland. All right, we'll think of that thing in there. I want to do one other thing. Okay, well, I'm going to add it on here. I'm sorry, I thought I had it on here. Alright, yes, you get my pen. Okay, there's basically, the AP test has started asking more specific questions. There are two parts to your hypothalamus. You've got your ventromedial hypothalamus. I'm going to spell as best as I can. Ventromedial. That's an A. You can't tell that's an A. Okay, ventromedial, and then the other half is your lateral hypothalamus. So basically they found the two parts of the hypothalamus. One tells you to eat, one tells you to stop eating, right? Your body, you know, after you've had one bowl of ice cream, your body tells you you need to stop. Now, do you always listen to that? No. But your body tells you when to eat and when not to eat. Okay? So the way I tell people to remember, lat sounds like fat. So lateral tells you to eat. And ventromedial tells you to stop. I think it's a different chapter. We'll talk about this, but they've had this rat who they destroyed its ventromedial hypothalamus. What do you think happened to it? It got huge, like massive rat, and stopped. It never stopped eating, and died because of that. Okay, let's see what I do next. All right, here we go. How do I go back to that? all done with you. Thank you. Did we get all parts of that? Okay. Over here, the hippocampus. That's the one they kind of forgot. Hippocampus has to do with memory. It helps you retain information, so it's involved with memory. So I'll write memory next to it. How are you going to remember that it's involved with memory? Well, if you're on a school campus, or if you're on a campus, then you're in school, man. You better remember things. You're going to fail school, fail life. Right? Okay. And then pituitary gland, we talked about that already. It's called the master gland, and it's part of what system? The endocrine system, right? It's a gland. Why it's here is because it is involved, it kind of works in conjunction with the hypothalamus. So the brain kind of controls the master gland, and then the master gland controls all the other glands. Okay? Okay. We're going to stop there. We already did that. Like I said earlier, we are going to make videos where you have to show each brain part working. You're going to be with a partner. And so that's one thing you can kind of think about of how will I show the medulla working, amygdala, reticular formation, thalamus, cerebellum, hippocampus, and hypothalamus. All right. All right. This weekend I want you to read those 2 modules, and you should have at least half of your summaries done. Okay, bye guys.